China is planning to build a nuclear power plant on the edge of the Gobi Desert that would be the first in the world to use molten salt as the fuel carrier and coolant.
80 years ago, the United States pioneered a revolutionary nuclear technology. Now, in an isolated stretch of China's Gobi Desert, that forgotten dream has roared back to life. China has just launched the world's first fully operational thorium molten salt reactor. And while most of the world is still obsessed with uranium, Beijing has leapfrogged into the future with a safer, cleaner, nearly waste-free alternative. Could this silent shift reshape the world's energy dominance? The fuel America left behind. Once upon a time, thorium was America's next big thing. Buried in beach sands and abundant across the globe, this silvery metal had the power to change everything about nuclear energy. It didn't explode, it didn't produce long-lived waste, and it couldn't be weaponized. In fact, back in the 1950s and 1960s, scientists at Oak Ridge National Laboratory in Tennessee were seriously exploring thorium as the future of atomic power. They even built a working prototype reactor powered by it, a molten salt reactor, which we'll get to in a bit. But then something strange happened. The US walked away. Not because thorium failed, but because it couldn't help build bombs. Thorium is a fertile element, meaning it needs to absorb a neutron to become uranium-233, which then fissions to release energy. That's great for energy, but not for weapons. So while thorium was safe, efficient, and abundant, uranium and plutonium were better suited for Cold War stockpiles. The military dictated the energy direction, and thorium was left behind, gathering dust in the archives. This abandonment wasn't just short-sighted, it was tragic. Thorium doesn't produce the same dangerous isotopes that uranium does. It's resistant to meltdown scenarios, doesn't create bomb-grade waste, and its radioactive byproducts decay within a few hundred years, not tens of thousands. In short, it's the kind of nuclear fuel the world wishes it had embraced, but didn't. Why? Because in the Cold War mindset, dual use was everything. If your reactor couldn't also churn out weapons-grade material, it wasn't worth the investment. The US threw its weight behind light water reactors powered by uranium, which could feed both civilian grids and nuclear arsenals. Thorium, with all its peaceful potential, became an inconvenient footnote. But the story doesn't end there. In the 1990s, much of the research from Oak Ridge was declassified. The blueprints for the molten salt reactor were released to the public. Anyone could access them. Anyone could build on them. And one country quietly took notice, not to build bombs, but to build the future. So if the US had the technology all along, what exactly was it? And why was it considered too advanced to use? Molten salt. Imagine a nuclear reactor with no pressure, no boiling water, no risk of meltdown, and almost no waste. Sounds like a fantasy, right? That's exactly what molten salt reactor, MSR, technology promised over 60 years ago. And yet, it was deemed too radical, too unfamiliar, and too politically inconvenient to pursue. Until now. Here's how it works. Instead of using solid uranium rods submerged in pressurized water, MSRs dissolve nuclear fuel, like thorium or uranium-233, directly into a molten salt mixture. That glowing liquid circulates through the reactor, transferring heat to a turbine system that produces electricity. Because the salt has an incredibly high boiling point, over 1,400 degrees Celsius, there's no need for pressurized systems. That means fewer moving parts, less chance of rupture, and almost no risk of a catastrophic steam explosion. But the real beauty of the design lies in its safety. Underneath the reactor sits a plug of frozen salt, kept solid by active cooling. If the power fails, whether from an earthquake, cyber attack, or even war, the cooling stops, the plug melts, and the liquid fuel drains into passive storage tanks where the reaction stops naturally. No explosions, no meltdowns, just gravity and chemistry doing their job. The Oak Ridge team in the 1960s ran a molten salt reactor for years. It worked. It produced power. It was clean, safe, and reliable. So why was it abandoned? because it didn't fit the playbook. Light water reactors were already being rolled out across the country. There were contracts, suppliers, and infrastructure built around uranium. Switching to MSRs would have meant rewriting the entire nuclear industry. Not to mention, MSRs couldn't produce plutonium-239 for weapons, and in the Cold War, that mattered. So who finally picked up the torch? And where is this radical reactor running today? Inside China's silent breakthrough in the desert. Thousands of miles from the skyscrapers of Shanghai and the political halls of Beijing, an unassuming hum resonates across the wind-scoured sands of the Gobi Desert. There, in a region so barren it might as well be another planet, China pulled off something the West gave up on decades ago. In the middle of this hostile environment, without fanfare or even a press conference, the world's first operating thorium molten salt reactor, TMSR-LF1, quietly came to life. The achievement was as symbolic as it was scientific. TMSR-LF1 reached criticality in October 2023, a milestone that meant the reactor had begun a self-sustaining nuclear reaction. But unlike traditional uranium reactors, this system didn't need massive cooling towers, pressurized chambers, or gallons of water. Its fuel and coolant were one and the same, a cocktail of molten salts laced with thorium. The result? A nuclear reactor that could run in the middle of a desert, cooled by air alone, impervious to the water scarcity challenges that plague conventional systems. By mid-2024, the reactor was generating 2 megawatts of thermal energy. While that number may not turn heads in the conventional nuclear world, the importance lies not in the quantity, but in the quality of operation. This wasn't about powering a city, it was about proving a paradigm. And in October 2024, the reactor did something no commercial reactor has achieved. It was refueled while still running. No shutdown, no restart, just continuous, stable output. A concept long dreamed of by engineers, but never successfully realized at scale. At the center of this quiet revolution is Dr. Xu Hongjie, a physicist from the Shanghai Institute of Applied Physics. With little more than a skeleton crew at the start, Xu led a team that expanded to over 400 experts in just 2 years. Their mission? To revive the molten salt technology pioneered by Oak Ridge National Laboratory in the 1960s. And to do what the Americans never finished. They scoured old declassified documents, modernized reactor designs, solved corrosion issues, and built a fully operational system, all without the headline-hungry posturing that often accompanies such breakthroughs in the West. Why the Gobi Desert? The reasons are both practical and symbolic. It's a secure, remote location with little risk of outside interference. But it's also a place where nothing grows, a stark backdrop for planting the seeds of a future that could change the world's energy landscape. The choice says everything. While others argue about the risks of nuclear innovation, China is quietly building it in the silence of the sands. So what's next? Just how far and how fast is China planning to scale this up? Scaling the impossible. If the TMSR-LF1 was the opening act, China's long-term thorium strategy is shaping up to be an entire symphony. The success of the desert-based prototype was never the end goal. It was a springboard. And now China is preparing to do what it does best, take a successful pilot and mass-produce it into a global standard. The playbook is familiar. It's what China did with solar panels, high-speed rail, and electric vehicles. And now, the same industrial strategy is aimed squarely at thorium. According to reports from the Chinese Academy of Sciences and internal documents from the Shanghai Institute of Applied Physics, the plan is both bold and comprehensive. The first step? A 10-megawatt electric reactor by the year 2030. This reactor won't just be a proof of concept, it will be a commercial-ready prototype, able to feed electricity directly into the grid. More importantly, it will establish the technical foundations for modular production, standardized thorium reactor units that can be manufactured in factories and shipped globally. These next-generation units are designed to be compact and self-contained, generating up to 100 megawatts of electricity each, enough to power a medium-sized city or an industrial zone. Built to fit inside container-sized modules, they can be deployed to remote regions, border installations, off-grid mining sites, or disaster zones. Their portability and scalability offer a revolutionary approach to energy deployment, one that doesn't require massive infrastructure or long development timelines. But it doesn't stop at land. China is also exploring thorium-powered naval propulsion. Imagine cargo ships crisscrossing the Pacific, never refueling, never emitting carbon. In a single move, that could rewrite the rules of global shipping logistics and undercut diesel dependence forever. Similar designs are being floated for offshore power plants and island bases, making thorium reactors the Swiss Army knife of strategic energy independence. Another critical feature of the roadmap is integration. Rather than replacing renewables, thorium will complement them. China plans to pair these reactors with solar farms, wind turbines, and battery banks to create hybrid energy hubs. These hubs could supply energy 24/7, solve storage issues, and ensure power continuity during cloudy days or windless nights, something current renewable systems struggle with. Ultimately, this roadmap is not just about energy. It's about geopolitics, resilience, and dominance. If China can produce, deploy, and export these reactors before the West even approves one, it won't just be selling a product. It will be setting the global standard for 21st century energy. But building the future is one thing. Reshaping global power, that's where things get even more interesting. The geopolitical fallout. In global politics, energy has always been more than just a utility. It's leverage. In the 20th century, oil determined empires. Pipelines influenced invasions. Petrostates shaped diplomacy. But in the 21st century, the game board is shifting. As fossil fuels face mounting environmental and political backlash, electricity becomes the new lifeblood of power, and whoever masters the next generation of electrical infrastructure will quietly pull the strings of the future. Enter thorium, and enter China. Unlike uranium reactors, which often come with international scrutiny and military baggage, thorium offers a clean slate. It's safer, more abundant, and harder to weaponize. For countries wary of Western dominance or entanglement, it's the perfect gateway to nuclear-grade energy without triggering geopolitical alarm bells. And China, it's positioning itself as the global vendor for that gateway. Reports from the China National Nuclear Corporation and international think tanks like the International Institute for Strategic Studies, suggest that China is already in quiet negotiations with several emerging nations: Kenya, Nigeria, Laos, Pakistan, and even Egypt. The offer: turnkey thorium reactor installations bundled with financing, personnel training, grid integration, and long-term maintenance contracts. It's the nuclear version of what China already does with railways, ports, and telecoms under the Belt and Road Initiative. Only this time, it's even more strategic. Consider the implications of building a thorium reactor in rural Kenya. It's not just about supplying power. The reactor brings Chinese engineers, Chinese software, Chinese safety protocols, and perhaps most importantly, Chinese energy diplomacy. That power station becomes a node in a new global network, one where Beijing controls the flow of electrons, education, and influence. Unlike military bases, which provoke resistance, energy partnerships foster reliance. You don't need tanks when you control the plug. This is soft power at its most elegant. Through energy, China builds loyalty, not through threats, but through infrastructure. Countries become partners, not because they're coerced, but because they see value, and because there's no better alternative. The West, tangled in legal red tape and internal political chaos, can't offer reactors fast enough, cheap enough, or simple enough to compete. And beyond the reactor sites, China's strategy includes control of the entire value chain: thorium mining, molten salt manufacturing, and education exchanges for reactor technicians. Over time, this creates a global class of nuclear professionals trained in Chinese doctrine and technology. another layer of soft influence spreading through technical, not ideological, means. If enough countries adopt Chinese thorium systems, it's not far-fetched to imagine Beijing pushing for new international safety standards that reflect its designs, or even for new treaties that subtly exclude Western uranium-based frameworks. This quiet reordering of norms doesn't make headlines, but it's how empires are built in the modern world. And while China surges ahead, the country that first imagined all this, America, watches from the sidelines. But why? Why the West let go of the future? 80 years ago, the United States led the world into the atomic age. From the Manhattan Project to Oak Ridge National Laboratory, America was at the frontier of nuclear innovation. It was here, in the 1960s, that scientists first ran molten salt reactors using thorium, years ahead of anyone else. But instead of pursuing the peaceful atom, Washington made a choice. Uranium over thorium, weapons over waste reduction, politics over sustainability. Why did this happen? Part of it was strategic. Uranium reactors produce plutonium, a key ingredient for nuclear bombs. In a Cold War world, that mattered more than long-term safety or efficiency. Thorium, by contrast, couldn't easily fuel a weapons program, so it was shelved. But the deeper problem was institutional inertia. By the time the Cold War ended, the US nuclear industry had entrenched itself around uranium-fueled light water reactors. The regulatory system, supply chains, contractor networks, all of it was built to support a status quo that favored complexity and familiarity. Switching to thorium would have meant reinventing everything, training new staff, rewriting laws, developing new safety codes. It was cheaper and easier to maintain the old system, even if it was inferior. Today, that legacy haunts the US nuclear landscape. While China runs its first thorium reactor, the United States still struggles to build new uranium reactors on time or on budget. The Nuclear Regulatory Commission doesn't even have a dedicated licensing framework for molten salt designs. Startups like Flybe Energy and Transatomic Power have tried to push forward, but quickly found themselves mired in paperwork and uncertainty. Some, like TerraPower, funded by Bill Gates, have opted to build sodium-fast reactors instead, because the path of least resistance still leads away from thorium. Meanwhile, Congress dithers. Climate bills come and go, often diluted by partisan politics. Research funding for alternative nuclear is sporadic and insufficient. And large-scale investment in thorium? Still a fringe idea, discussed more in YouTube documentaries than in Senate hearings. The irony is that America has the talent. National labs like Argonne and Los Alamos still house world-class nuclear scientists. Universities like MIT and Caltech have hosted thorium research teams, and US thorium deposits remain among the most extensive in the world. The pieces are there, but the will is missing. A few voices have called for change. Some propose a Thorium Manhattan Project, a bipartisan crash program to reignite the old molten salt flame. Others push for reforms at the NRC to enable faster, smarter licensing of new nuclear technologies. But unless these ideas become policy, the US risks becoming a buyer, not a builder, in the new energy order. But the world doesn't wait for America to catch up. Will the rest of the world follow China's lead, or carve a new path? Who follows China's lead? As China quietly activates its thorium-fueled future, the rest of the world faces a fork in the road. Will nations double down on outdated uranium infrastructure, or will they follow Beijing's blueprint and make the leap into molten salt and thorium-based energy? It's not just a matter of innovation. It's a question of sovereignty, economics, and survival in a rapidly warming world. Several countries are already watching China's moves with cautious interest. India, for example, has one of the largest known thorium reserves in the world, particularly along its eastern coastline. The country has been toying with thorium reactor designs for decades, but has struggled to bring any of them to full operation. Until now, its advanced heavy water reactor programs have been stuck in the experimental or prototype phase. But with China demonstrating a working system, pressure is mounting on Indian officials to ramp up development and avoid being left behind in the regional energy race. Russia, too, has begun investing in thorium and molten salt designs, although its focus remains largely on fast breeder reactors and uranium cycles. Still, several Russian labs have resumed R&D on thorium-based fuels in response to Beijing's breakthrough. Elsewhere, countries like Canada and Norway have expressed interest in collaborating on international thorium research, seeing it as a path to cleaner baseload power without geopolitical strings attached. Meanwhile, Gulf nations like Saudi Arabia and the United Arab Emirates, eager to transition away from oil dependence, have reportedly explored thorium partnerships with Chinese reactor developers. These states understand the long game. Whoever controls next-generation energy infrastructure will control future trade, innovation, and influence. Yet, there are holdouts. Many Western countries, particularly in the European Union, are still hesitant. Regulations for thorium are underdeveloped, and public distrust of anything labeled nuclear remains high. France, Germany, and Austria continue to favor renewables, despite the intermittency issues that still plague wind and solar power. Ultimately, the global fork in the road will come down to one thing: results. If China's reactors continue to run safely, efficiently, and affordably, the dominoes will start falling. First, the curious partners, then the competitors, then the reluctant regulators. But if China stumbles, the skeptics will use it as proof that molten salt was never viable to begin with. If the world starts following China's lead, how will the global energy map shift? And who will be left out of the new order? The race to rewrite the grid. Thorium reactors aren't just about powering homes. They could completely upend the way we think about electrical grids. The traditional model is centralized, massive power plants pumping energy into a nationwide web. But molten salt thorium reactors offer something different, a chance to decentralize energy in a way that's never been possible before. Instead of relying on massive nuclear or coal-fired plants, regions install modular thorium units close to where energy is needed. Remote mining towns, Arctic research stations, island nations, military bases. Anywhere that traditionally struggles with energy access. These compact reactors could operate for years with minimal oversight, reshaping the very idea of an energy grid. China knows this. Its long-term energy roadmap includes hybrid stations that combine thorium reactors with renewables and battery storage, miniature, resilient grids that operate independently or in sync with national infrastructure. That means fewer blackouts, fewer long-distance transmission losses, and faster recovery during disasters. But here's where it gets even more strategic: export potential. China isn't just building a domestic energy fortress, it's designing reactor units that can be sold, shipped, and installed globally. That's not just infrastructure, it's influence. A power grid where the software, parts, and maintenance come from Beijing is a power grid built on dependence. The implications for countries with unstable energy supplies or growing geopolitical rivalries are massive. Thorium reactors could offer energy independence to some, but to others, it could signal a new kind of dependency. Will the West counter with its own thorium grid strategy? So far, no major Western nation has proposed anything equivalent. Instead, decentralized energy efforts are focused on wind, solar, and grid-scale batteries. Effective, yes, but vulnerable to outages and less stable over long durations. If China succeeds in deploying modular thorium energy across rural regions, developing nations, and critical infrastructure points, it could own the very DNA of the next global energy system. But China's grid plans are just the beginning. What about the next evolution of thorium itself? What comes after TMSR-LF1? TMSR-LF1 was never meant to be the final product. It's a stepping stone, a proof of concept. And now that it works, China's plans for what comes next are unfolding fast, and they're nothing short of audacious. By the early 2030s, China plans to launch a 10-megawatt electric molten salt reactor, one that will actually feed power into the grid and test long-term operation at scale. That alone would make headlines. But it's only the beginning. The real breakthrough lies in modularization. These reactors won't be massive, one-off projects requiring years of planning and local permits. They'll be built in factories, trucked to their destinations, and installed like industrial appliances. This is a revolution in how nuclear energy is deployed. Think plug-and-play reactors. Not one every 10 years, but dozens, or even hundreds, within a single decade. And China isn't just targeting the domestic market. They want to export them. Africa, Southeast Asia, Latin America. These regions have limited nuclear infrastructure, but massive energy demand. And with the West largely hesitant to export nuclear tech, China sees a clear opening. And then there's the Holy Grail: waste reduction. Future thorium reactors, using advanced configurations, may be able to reprocess and consume old uranium waste. This would solve two problems at once: generating clean power while cleaning up legacy stockpiles. A win-win scenario that would make thorium reactors even more appealing politically and environmentally. But challenges remain. The metallurgy of molten salt systems is tricky. Corrosion is a major issue, and materials must be engineered to withstand decades of high-temperature flow. There are also regulatory hurdles. Most nuclear agencies still lack clear pathways to approve molten salt reactors. China has the political will to fast-track this. But in other countries, that red tape may take years to cut through. But if China's just getting started, what happens if the rest of the world doesn't catch up? Energy sovereignty. In an era defined by fragile supply chains and global uncertainty, energy sovereignty is becoming the new national defense strategy. And thorium, it's the ultimate shield. For China, thorium isn't just about clean energy. It's about independence. From fossil fuel imports, from uranium suppliers, and from geopolitical energy choke points. Most countries rely heavily on imported energy sources: oil from the Middle East, natural gas from Russia, uranium from a handful of specialized providers. But China's vast thorium reserves, especially in provinces like Inner Mongolia and Sichuan, change that equation. According to geological surveys by the Chinese Ministry of Natural Resources, China's domestic thorium reserves could power the country for up to 25,000 years. That's not just enough for a generation. That's enough for multiple civilizations. This makes thorium more than a scientific curiosity. It becomes a geopolitical tool. When the world is locked in resource competition, the nation with an unlimited, self-sustaining energy source has the upper hand. No blockades, no embargoes, no OPEC-style power plays. Just a homegrown power system that quietly hums through every factory, city, and ship. But thorium's advantage doesn't stop at supply. Unlike uranium, thorium is virtually unusable for nuclear weapons without an extremely complex enrichment process. This removes much of the international scrutiny that comes with traditional nuclear programs. For China, that means fewer diplomatic hurdles and less fear of sanctions or intervention. The implications for global security are massive. Imagine a world where China provides energy security to its allies, countries that previously relied on fossil fuels or American nuclear tech. With thorium, Beijing can offer something no one else can: energy autonomy without military entanglement. And the optics? Impeccable. China gets to wear the clean energy crown while subtly tying entire regions into its technological ecosystem. But what happens when energy becomes more than just a weapon or a resource? What if it becomes a story China tells the world about itself? The propaganda power of innovation. Behind every technological leap is a story, and China is mastering the narrative. The launch of the TMSR LF-1 wasn't just a scientific milestone, it was a stage. A carefully crafted performance meant to send a clear message to the world: the future belongs to us. State media didn't shy away from using cinematic language. The dawn of a new atomic era proclaimed headlines on CGTN and Xinhua. Documentaries aired within days of the reactor reaching full power, highlighting not only the science but the people, the engineers, scientists, and families who made it happen. Even the desert landscape was romanticized, a futuristic outpost emerging from barren wasteland. This isn't just hype, It's soft power. It's the same strategy used to frame China's high-speed rail, its lunar landings, and its dominance in green technology. By showing the world that it can build what others only theorize, China isn't just changing facts, it's changing perception. And in the modern age, that's often the same thing. Inside China, this narrative fuels nationalism and unity. Outside, it creates admiration and envy. Countries struggling to meet carbon goals are watching closely. Young scientists across Africa and Southeast Asia are looking to Chinese universities instead of American labs. In a world that's increasingly skeptical of Western leadership, China's ability to say, "We did it first," is powerful. And thorium, it's a golden opportunity to frame China as not only a leader in innovation, but also a responsible steward of the planet. Clean, safe, sustainable nuclear power, without warheads, without waste, without fear. The irony is hard to miss. Once dismissed as a lagging industrial state, China now uses thorium reactors to rebrand itself as the champion of the future. It's not about reactors anymore. It's about legacy. And as China writes this new story, the clock is ticking for the rest of the world, especially for America. Will they wake up in time? The clock is ticking. While China fuels its future with thorium, the West remains caught in limbo. Projects stall, budgets get slashed, political will ebbs and flows. But here's the harsh reality: the world won't wait. And the longer the US and its allies delay action, the further they fall behind. Not just technologically, but diplomatically and economically. America still holds many cards. It has world-class research institutions, deep pockets of thorium reserves in states like Idaho and Colorado. It was the birthplace of molten salt technology. But none of that matters without coordination, funding, and urgency. What's missing is a unified Manhattan Project-style push, a national plan that says, "We're all in." Instead, America's energy strategy remains fragmented. The Department of Energy funds scattered pilot programs. Private firms pursue disparate reactor designs. And Congress? It's too busy arguing over short-term climate bills to build a long-term nuclear roadmap. Meanwhile, China is already exporting reactor designs. India is accelerating thorium R&D. And countries once loyal to Western tech are turning east for solutions. If this trend continues, the West won't just lose the energy race, it'll lose the power to shape the rules. It doesn't have to end that way. The technology exists. The talent exists. What's needed now is vision. Leaders willing to look past election cycles and into the next century. Thorium could be the key to clean power, energy independence, and climate survival, but only if it's embraced boldly. If not, America might find itself importing molten salt reactors from the same country that once learned the technology from declassified US archives. So what started as a forgotten metal buried deep in science history has become the centerpiece of a global energy shift, and China is driving it. The thorium revolution is no longer a theory. It's running, humming, and reshaping power, literally and geopolitically. Do you think the rest of the world will catch up in time? Let us know in the comments below, and don't forget to watch our next video where we dive into another game-changing breakthrough.